Hi guys, today we're going to go through ionic bonding and we'll do that in a bit more detail in a second, but first let's get on with the starter. What is the trend in reactivity as you go down group 7? Well, at the top of group 7 is fluorine and that's the most reactive element, so as you go down group 7 it becomes less reactive. Next one, what is the trend in reactivity as you go down group 1? Well, it's the opposite to group 7. They become more reactive as you go down the group. And finally, who discovered the neutron? This was a man called James Chadwick. We've done this a couple of times now, so hopefully you remembered that one. Right, let's get on with today's lesson. So this is a definition or a series of bullet points that's going to explain ionic bonding, and I'll talk through them as we go. So the important thing is that ionic bonding occurs between a metal and a non-metal. That's really important. This is the only type of elements that are involved in ionic bonding. Metals, for example, magnesium, and a non-metal, for example, oxygen. And they react together to form an ionic bond. The second question says that the metal atoms lose electrons and they become positive. And we talked about this in my video ions. So if you don't understand this in quite as much detail as you should, maybe go back and watch that. So metal atoms lose electrons, they give them away. And when you give away your electron, you then become positively charged because you've given away all your negatives. Now, the next one says non-metals gain electrons. Well, these electrons have had to go somewhere, and it's the non-metal that accepts them. And then they become negatively charged because they've taken on more negatives. And when they do this, the reason for it is to gain a full outer shell. That's what they're trying to do. Metals are trying to give away their electrons to get a full outer shell, and the non-metals are trying to accept those electrons to gain a full outer shell. Okay, let's go and look at this in a little more detail with some diagrams to help. So here's an example. They all want to achieve a full outer shell, and we have magnesium here. Magnesium is a metal, and if I wanted to work that out, I'd look at the periodic table, and I'd see that it was on the left-hand side, so it must be a metal. Now, if you notice, magnesium has 2 electrons in its outer shell here. Now, its inner shell here, this one, is full. So if it could just lose those electrons, its next shell would be full. And that's what it does. It gives away its electrons to become Mg2+, because it's lost 2 electrons, so it becomes Mg2+, and then it has a full outer shell. So now it's stable, or it's happy at least. So what magnesium needs to do is react with something that needs 2 electrons, or 2 things that need 1 electron. And that way it's got somebody or something to give those electrons to. So this is going to be a hinge point question. This links to our video on ions. So I want you to look at these 4 examples and try and work out how many electrons they would like to either lose or gain to get a full outer shell. So pause the video, have a go, then unpause for the answers. Right, hopefully you've had a go at this, and here are the answers. Calcium is in group 2, so it would like to lose 2 electrons to become 2+. Sodium, group 1, so it becomes 1+. Chlorine is in group 7, so it only needs to gain 1 electron to get into a full outer shell, so it becomes 1-. Oxygen, group 6, so it needs to gain 2, so 2-. If you didn't understand that, it's time to go back and watch the ions video. If you do, let's move on. So now we're going to look at constructing ionic dot and cross diagrams which represent ionic bonding. And it's also a very good way at showing what's happening to the electrons. Where are they going? Who's losing them and who's gaining them? So this one here is a reaction between a group 1 metal, sodium, and a group 7 non-metal, chlorine. So let's have a look. And for ease, I'm only going to draw the outer shell electrons. So sodium's in group 1, so it has 1 electron. And it's going to react with chlorine, which is in group 7, and will have 7 electrons in its outer shell. And you'll notice these are called dot and cross diagrams. So I've done 1 cross here, so the rest on the other element must be dots. So 7 dots. 1, 2, 3, 4, 5, 6, 7. Now it doesn't matter which element has the dots and which has the crosses. It just matters that they're different. They can't both be dots and they can't both be crosses. This is a very good way at showing where the electrons came from. I know that all the dots belong to chlorine and all the crosses belong to sodium. Now, how can this chlorine gain a full outer shell? It needs 8 electrons. Well, it only needs 1 extra electron to get a full outer shell. So sodium donates its electron to chlorine. Wonderful. Sodium's happy because it's got no electrons, or its next inner shell is full, and chlorine's happy because its outer shell is full as well. So now we need to draw this, thinking about what's happened to the electrons. And it's also a good thing to point out that you need to remember that when elements gain electrons, they become negative, and when they lose electrons, they become positive. And you'll see why in a second. So let's start with sodium. Sodium has lost an electron, so there's no more electrons in that shell. So we just leave it like that. And because it's lost an electron, it's become positive by 1. So we just do brackets to show the charge, and then we put the charge outside the brackets. And this tells me that this sodium has lost 1 electron. The chlorine, on the other hand, has gained the electron from sodium. So we need to draw that in. So we do the 7 dots that chlorine already had to begin with. But now what we're going to do is we're going to add in sodium's electron, which is a cross. So just like that. And you can see we now have a full outer shell here. And it's also gained 1 electron. So we need to do the brackets, remember, to show this. And because it's gained 1 electron, that's 1 negative. So you put negative charge there. And that's all there is to it. I know it's a lot, so we're going to do another one just to make sure we understand what's going on. So here's an example, this time with a group 2 metal and a group 7 non-metal. So we have calcium. Calcium is in group 2. So it has 2 electrons in its outer shell. Chlorine is in group 7. So it has 7 electrons in its outer shell. And hopefully you spotted that we've got a bit of a problem here. Calcium needs to get rid of these 2 electrons to gain a full outer shell, but chlorine can only accept 1. So I want you to pause the video and have a think about what you might need to do in order to satisfy calcium and chlorine. So pause the video, have a think, and then unpause for the answer. Right, hopefully you've identified that we need to get rid of 2 electrons, but chlorine can only accept 1. So what might be a good idea to do, if we have 2 chlorines, then each chlorine would be able to accept 1 of those electrons from the calcium. So I'll draw them. Here's the other chlorine. And I'm going to get rid of this 2 to get rid of any ambiguity. And now what you can see is that calcium can donate 1 electron to that chlorine and the other electron to that chlorine. So when we go to draw the ionic compound at the end, we need to make sure we take this into account. So we draw the calcium with no electrons in its shell, and we do the brackets to show how many electrons it's lost. It's lost 2 electrons, and when you lose electrons, you become positive, so 2 plus. And then the other element is your chlorine, and we have 2 of those chlorines. 1, 2. So we need to put a 2 outside the brackets, draw our chlorine, and you only need to draw 1 of them, so like that. And each chlorine has gained 1 electron. So when you gain electrons, you become negative, and there you have it. Now these are really tricky. So have a look, go back through each of these videos again and make sure you understand why elements lose and gain electrons and also how to represent it in an ionic dot and cross. And then I'd like to have a go at these questions. If you're stuck at any point, please put a comment in the box below and I'll do my best to do a worked example for any of these questions. It does take some time and you may not understand it from this video. You may need to go back and maybe ask your teacher or try and get a bit more support through this video. Okie dokie, that's all we have time for today. Here's the 4 questions for you to finish up on. Have a go, let me know how you got on. Speak to you soon. Bye.